Hello class. Today we will be learning how to find velocity final in a given situation given that it is under UAM principles. A ball is dropped 1 meter above the ground from rest. Assuming there's no air resistance, what is the velocity final of this ball?
Okay, so velocity initial is 0 because since the ball is starting from rest, it will be at 0. And total displacement is 1 meter because the meter stick measures the initial distance and the final distance, which equates to 1 meter. And we know acceleration because assuming that there is no air resistance, the object is in free fall, which means that gravity is acceleration. And we can use these three UAM variables and plug them into the UAM equations to find the remaining two, which are time and velocity final. The free body diagram will look like only a gravitational force pointing down because assuming that there's no air resistance, the object is in free fall. And Derek will show you how to find the remaining two variables using the UAM equations.
Thanks to Eric's great explanation and demonstration, we know the velocity initial of the ball is equal to 0 meters per second. We know displacement or change in position of the ball is equal to 1 meter. And we also know acceleration is equal to gravity. Now we should draw how the ball looks on the diagram. So it's simply going to drop down, traveling a total displacement or change in position of 1 meter. We also know velocity is equal to change in position over change in time, while acceleration is equal to change in velocity over change in time. Now, since we have 3 of the UAM variables, we can solve for the other 2 UAM variables. However, in this problem, we're simply looking for velocity final. So to solve this, we're going to look at our 3 UAM equations. Now, we should use the third UAM equation because it states that velocity final squared equals velocity initial squared plus 2 times the acceleration times the change in position of the ball. Now, we are going to use this equation because we have 3 out of the 4 variables in this equation, so we can solve for the missing one, and also using algebra skills. And that missing one variable is what this question is asking for, velocity final. So now we do not know velocity final, so we're just going to keep it as velocity final. We're going to set it equal to 0 squared, which is just 0, plus 2 times gravity, since acceleration is equal to gravity, times the change in position of the ball, which is equal to 1. Now, simplifying this with algebra skills, we get velocity final squared equals 2 times gravity. Now, we know gravity is equal to 9.81 meters per second squared. Keep in mind this units of meters per second squared because acceleration's base units is meters per second squared. As you can see, velocity is meters per second, while displacement is simply just meters. Now, subbing these variables in, we get velocity final squared is equal to 19.62. Now, we have to take the square root of both sides since velocity final is squared. Keeping that in mind, we get a velocity final of 4.429 meters per second. Please keep in mind that we got a positive velocity final because the problem told us to assume that the downward direction is positive in this case. So the displacement is 1 meters positive, which is why we get a positive final velocity. However, if the problem said that the positive direction is pointing upwards, then the displacement of the ball would be negative 1 meters because displacement has both magnitude and direction, and since velocity is equal to change in position over change in time, or displacement over change in time, velocity also has magnitude and direction. So if positive direction pointing upwards, you would get a final velocity that is negative. In this lesson, we learned how to calculate velocity final under UAM principles, given that we know 3 out of the 5 UAM variables. Thank you.
Now that we've thought about the scenario in terms of kinematics by finding the final velocity, let's look at the scenario in terms of a dynamics problem. If a 0.5 kg ball falls from rest and free fall onto the ground, what is the magnitude of the force exerted by the ball on the ground, and vice versa? So it's the magnitude of the force of the ground onto the ball. Now you may think greater velocity, greater force, but this simply is not the case. As you can see in Newton's second law, the net force equals the mass times the acceleration. And since the ball is in free fall, we know that the acceleration is equals gravity, which is equal to 9.8 meters per second squared. And since it states right here that the ball is 0.5 kg, we know the mass equals 0.5 kg. So if we write this equation again, net force equals mass times acceleration, so then which equals 0.5 times 9.8. And let's make sure we have our units. It's always something you want to do in physics. And so if we multiply 0.5 times 9.8, we get 4.9 newtons, which is the units for force. Now, that's the force that the ball exerts on the ground. But now you may be thinking, what about for the force the ground exerts on the ball? Well, we can figure this out using Newton's third law. With the third law, we know that the net force is zero, as you can see in this diagram, as the normal force is a reactionary force to the gravity, the ball landing on the ground. So we know Fn minus Fg equals 0. That's another way of writing net force. But since we know Fg equals 4.9 newtons, we can input Fg for 4.9 newtons. So we have Fn equals Fg. So Fn equals 4.9 newtons. Now we know the force the ground exerts on the ball and the force the ball exerts on the ground. So we solved the question. It's 4.9 newtons in both ways.